here we are in Godot 4. We have a tile map here with several layers set up in the property editor. Each layer gives the map a different information. So we have the outer walls, which act as our outer boundary. We are using TileMaps just to add some physics and also so we can add metadata. Then we have the inner rocks. We have spawn points, and we have our explodable tiles. So these can be covering, and then I've just got a couple of the harder blocks just for visual design. The advantage of using the tile map is just so we can see what it's going to look like and see what we're doing. So that's why the outer wall is using the tile map with some collision. And then what we do is we add a C# script, and this is it. So what I like to do is set up an enum with each layer just so that we can easily interact and know what we're doing. We've got a node path to the world and a packed scene for an explodable block, which is going to replace the explodable blocks on here in a random manner. These are just tiles, but what we actually want is an interactive rock with animations and information and some scripts attached to it. So first of all, what happens is we don't want to see the outer boundary. So that layer is hidden, and that is done by setting the modular layer with a new color that has an alpha of 0. Then what we do is disable the spawn point layer, and we disable the explodable blocks layer since we do not want to see those. They're just for design. However, what we do want is the information within those layers, which is the spawn point locations. So once the map has been built, spawn rocks is called, and I grab each layer. So if I follow this down, this is a really simple function. What it does is it uses get used cells from Godot, and that is called with the layer ID, and that corresponds to the layers in our enum. So outer walls will be 0, and explodable tiles will be 3. So to get all the tiles on a layer, get all used cells. This comes back as a Godot collection. However, I prefer to use lists, so I'm casting this to a list, and I return it as a list of vector to I. So here what I do is I get all the hard tiles, which are the tiles on the hard rocks layer. Then I get all the soft tiles, which are the explodable blocks, and I get all the spawn points. This is a little special function which gets all the spawn points that are defined within the tile map. However, it filters out any that are used by actors so that I know that I can't spawn a explodable block on top of them. So use soft blocks, basically it goes through the hard layers and any spawn points, and make sure to collect a final list of all the locations where it can spawn a new rock. Then what we do is we loop through and take away 40 of them just randomly, and then with our final list we go through all the grid locations and spawn them onto the map. So this is our other interactive function. What we do here is we call map to world with the grid location, which gets the position on the map the new instance should appear. So we add that to our world because we don't want it as a child of the tile map. We want it a child of the world at the location found by map to world. And that's it, really simple. So what we end up with is something that is easy to design with, and then we can interact with it and build our map and spawn our blocks. randomly.